Good day, I'm Jan Getz and I'm one of the volunteers in the water sampling program. And today we're going to look at how you do your water sampling. First of all, we're going to talk about the equipment that you need and then what you need to do before you go out into the boat. Every team receives one of these bins and it includes a binder, and a box, a bin that has a Secchi disc, a filter. You may have this type or this type, a thermometer, a collection bottle, potentially a bacteria sample bottle if that is on your requirements, or bottles for your phosphorus samples. You will also have a Sharpie that you use to put the dates on the phosphorus bottles, and a wax crayon that you use to put the site location on your bacteria bottles. In addition, you will need to have a cell phone, a cooler with ice, preferably ice cubes, and a life jacket. If you are missing any of these materials, and there is a list in your bin of what you should have, please let the office know to make sure that before you start to go in the boat that you are prepared with all the material. You need to become very familiar with your manual. The protocol is outlined in it, and it does change from year to year. So please make sure that you are familiar, whether this is your first year for sampling or you've done it for 10, 15 years. The other things now that we're getting ready to go out is know what the schedule is. There's a schedule for when you go out and requirement as to what you're going to do each time you go out. First of all, you're going to fill out your data sheet, and it will have the date, the time, the names of the trained samplers, and anything else that's there. It's very useful before you go out to put what locations you're going to and what you're going to be sampling for. In this case, this is the second week that we've been out. And so in this location, we're only doing a Secchi disc. But at location number 1, this is a 0, a deep water site. In location number 2, we're doing both phosphorus and bacteria. The other thing that you will note is, this is the sheet that goes with that to clarify so you know what it is. So this is the one, and as I said, in week 1, you did a phosphorus, but going through, you did a phosphorus and a bacteria, and that will continue on through. Be very careful. In many of the sites, there will be a duplicate in your 0 site on the first week. There's never bacteria on the first week because the water's too cold. You also will have a map that shows the location of your sites, plus picture visuals and the GPS coordinates. And those are very important in order that we have continuity from year to year. And I think once we've got that done, we're ready to go on into the boat. Now Chris and Louise are going to demonstrate deep water sampling. They've located the site using the GPS coordinates in their manual and matched that with the GPS on their cell phones, or possibly you've got GPS on your boat. Note the water conditions and mark that on your sheet. Today it looks very flat, so this works well. Hang the thermometer put it into the water on the shady side of the boat. It's best to have it tied to the boat so it doesn't get lost. And remove your sunglasses if you've got them on, and then start lowering the Secchi dish into the water. You're letting it go down until you can no longer distinguish between the black and the white segments. And once you reach that depth, please mark it at the water line to the nearest 1/10 of a meter onto your data sheet. Then continue to lower it, and then start to raise it again. That first measurement was Secchi down, and now as you're starting to raise it and you measure when you can again see the segments, that is your Secchi up measurement, again to a 1/10 of a meter on the data sheet. And again, mark it with the clothespin. The distance between Secchi down and Secchi up should be less than 1/3 of a meter. Next step is going to be to rinse the collection bottle twice. Now is the challenging part of deep water sampling, and that's attaching the collection bottle to the Secchi dish. You can see that there are rubber ties and elastics, and now what we're going to do is lower the disc with the bottle attached down to the Secchi depth. You want to get water through the whole column, so you lower it slowly down until it's about between the two clothespins in depth. Should take maybe 3 or 4 seconds, but wait until there's no more bubbles coming out. Bring it up carefully. And remove it from the dish. In the meantime, Louise is getting the sample bottle ready. No, first of all, she's going to get the filter and the sample bottle. You rinse the filter twice with the water that was in the collection bottle. And then run it through the filter into the collection bottle to the shoulder height. Don't overfill it. And you don't rinse the collection bottle because it does have special chemicals in it that we need, so be very careful when you're doing that. And of course, make sure it's the right bottle. Most of the deep water sites are 0. And then we're ready to move on to our next site. In this segment, Chris and Louise are going to demonstrate how to do a near-shore sampling. They've checked their coordinates to make sure that they're in the correct location and have drifted into the location, making sure that the bottom was not disturbed. The goal is to get as close to the shore, about 4 feet of depth if possible, and it's easier to do in a small boat or in the front of a bow rider. First job, Louise is going to put the thermometer into the water, and Chris is going to check first that the sample bottle and the site number match, while Chris is plunging, using a plunge and sweep method to fill the collection bottle. The plunge and sweep is put the water vertically upside down to about the forearm, turn 90 degrees, and sweep sideways. Once it's filled, sweep up. Make sure the bottle is full, the bubbles have stopped. He's now going to rinse the filter twice. And then using that water, they will fill the sample bottle up to the shoulder. And note, this bottle, which has material in it, is not rinsed. And then be careful when you close it up to make sure it's tight so you don't spill it on the way back. If you're doing, well, Louise is going to put it in the cooler first. This site requires a bacteria sampling, and so Chris is going to hope that his bottle is full enough that he can use that same grab for his bacteria sample. Again, the bottle is the lid is carefully removed, making sure that neither the top of the bottle or the lid are touched by your hands. Again, close the lid tightly, put it in the cooler. Now, we're going to retrieve the thermometer, record the temperature onto the data sheet, and note any abnormalities or things of interest. It could be construction taking place nearby, the presence of animals, or unusual vegetation growth. If you're concerned, you can leave this site after you've collected filled your sample bottle, and then do the samples later. If your site only requires a bacteria sample, you can use the the bacteria bottle on its own. It does not need to be rinsed. It's already been sterilized. You just use a plunge and sweep method. Put the lid on it and put it in the cooler. Okay, we've now returned to shore, and in this segment, Louise is going to show us what we do with the bacteria samples. It is important, as we said, to have them in a cooler, and so it's necessary now to transform them from the cooler into a fridge until we're ready to return them to the MLA office. Now, at this point, Louise has set up the incubator, and it will be warming up to reach the desired temperature of 37 degrees Celsius. And it takes a while to do that, so it has to happen ahead of time. This is one of the reasons why it's important that there's coordination between all of the people collecting samples for each of the team leads, because they're the only people who actually do the incubation, and all of the samples have to have been taken within 24 hours of the incubator. It's easier to both prep and read the results in daylight, so try and arrange that you can schedule it that way. It does take an hour for that incubator to heat up, and at the first time in the season, you want to make sure that you've tested it ahead of time. It might not have been quite right. The first step is to take out the number of collar plates that you'll need for your testing run and label them with the site numbers. And you also need a blank collar plate for the control test, which uses distilled water. And you need one of those for each incubator run. For each sample, after removing the lid, first of all, I think she has to go to the fridge to get the water, and then she is going to fill the collar plate. It's very important that you fill all wells of the collar plate. This is best done over a sink as it's messy. You do it with a back and forth motion for each set of rows, and then tap the collar plate gently to dislodge any bubbles. Make sure that all the wells are full by turning them in a good light to view, and then fill up any cells that are not full. Then you have to drain the excess liquid from the wells by turning the collar plate so that the water runs off a corner. A paper towel at the edge can assist in this, but don't let it touch the wells. Then check that the wells are still full. The water surface appears concave in each cell. If there's too much water, then the wells will run together when heated and the results are impacted. Put the lid on the collar plate and the bacteria bottle. And don't throw the partially filled bacteria bottle out until all the collar plates are safely in the incubator. You're going to repeat this procedure for each of your bacteria samples, and the blank, of course. And the blank is filled with distilled water. Now, it's best that the incubator is in an area with good circulation because it does have an odor. Some people have it on an outside covered porch if the weather is warm enough, otherwise inside. Put the collar plates in the incubator, which we've done, and then on your data sheet, note the preparation date and time. Make sure that the thermometer is visible inside the incubator without opening the lid. Keep the lid closed, but verify that the temperature is correct. Now, you can rinse the bacteria bottles and let them dry and put them in your bin to return to the MLA at the end of the season. Then, 24 to 27 hours after the collar plates are incubated, 26 is best, you can get the results for the bacteria testing. So 24 to 27 hours after the collar plates are incubated, you can get the results from the bacteria testing. It's a two-step process. First, you're going to count the blue cells, which indicate the coliform count. Then you're going to count the cells that are blue and fluorescent, which indicates the E. coli count. For the first step, it's best if you put the collar plate on white paper to count the blue cells. You can count every cell that has any blue in it. Put that number on the data sheet under blue. You can note that there are 96 cells on the collar plate. Sometimes if the collar plate is mostly blue, then you can count the cells that are still clear and subtract the count from 96.
Here is a collie plate that has, this one has all of the cells are blue, so I didn't have to do any counting because I know there's 96 cells, which is pretty scary, and this happens very rarely. This other one here, there's just a few blue down in the corner, but some of them are quite light blue. So this is how you can tell on white paper where they're blue, light blue. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'll mark that down. But this is 96.
Okay. Okay. So now that that's been recorded, you want to take the collar plates into a dark room and put them on a dark surface or black paper. So we'll turn the lights out here and just see how this works. We have a bit of a conflict between being able to film it and be dark. She's turning on an ultraviolet light and shining it on the collar plate so that she can count the fluorescent cells. Record the cells that are both fluorescent and blue under the data sheet where it says blue and fluorescent. And you can notice that those numbers are not going to be the same as the number of blue cells.
And you'll note on this one, none of them are fluorescent.
That's what we like to see.
Yes. The E. coli number is the most important number.
Now, if the blue and fluorescent count is 18 or higher, you will need to resample and should do 2 samples next time at the same location. Test a week later, so notify your team. You will likely need to rinse the bacteria sample bottles lids in very hot water and put lids on these for new samples. Occasionally, high readings are common and to be expected, which is why a retest is needed. If you are new to doing the testing, it's best to ask an experienced tester to assist you the first time, or you can watch them do theirs before you do yours. Hands-on experience is very helpful for this job.